Hello friends, welcome to my channel. So in this video, we are going to look at a daily challenge problem 930, binary subarrays with sum. This problem is a counting problem. Basically, we want to count the number of non-empty subarrays with a sum being the given goal, right? So the strategy we are going to use is dictionary and check. Also, we use partial sum in between. So this problem actually is very standard. So basically, we want to use data structure to solve problem. So here we are going to use dictionary. Some problems you can use set and check. For example, the two sum problem, right? You can use set and check. So here we are given a binary array called nums and an integer go. So we want to return the number of non-empty subarrays with a sum go. So a subarray is a contiguous part of the array. So you can look at these examples. So here in example 2, basically you just need to count how many subarrays of a length 5 subarray has, right? Because all the elements are 0 and the go is also 0. While the generic one, let's see, example 1. So here our go is 2. We want to find those subarrays with sum 2, right? So you can see this one, right? You can also end at 0, so this gives you 2. So also you can include this these two ones. So you can start from here or you can start from this 0. So overall, it gives you 4 of them. So the constraints, I'm going to just look at this one. So the length can be as long as 3 times 10 to the power 4. In other words, we need to consider time complexity when we design the solution. The last one is that the goal is less than or equal to the length, right? Because it's binary, right? And the sum is at most the length. This one basically is an consistency assumption. So with that said, we're ready to look at the analysis. So the big picture is actually very simple, right? Assume you have a list. Let's call this here's nums. I'm going to use a to represent this one. So if you start from 0, inclusive, and ending at I, you have a sum. Let's call it S1. Then if you continue after I, so then you get up to some G. Then you have S2, right? Then basically it implies, so A starting from I plus 1 and then ending at G. The sum will be S2 minus S1. Because we can continuously record these partial sums, so this will be very convenient to check from a certain index to another index the sum. So if this S2 and minus S1 happen to be the goal, it means that we find one such valid subarray with some goal. So this is our overall logic. So, but in order to record, we don't care too much about the indices, though we can get all the indices, but we just need to count at certain index how many, what's the frequency of this S1, right? For example, before G, if S1 appears 3 times, it means that you have 3 starting point, then ending at both all at G. Those are corresponding to 3 subarrays with some go. So that's the overall logic. So with that said, we can first write the code and then we can print some information so that you can get the details. So for this purpose, first I'm going to initialize a result variable. So this is the counting variable, right? To count how many valid subarrays. Then the final state of this result is what we want to return. And then also I need to use a dictionary to record this information, because if nothing included, so this partial sum is 0. So then here we are going to count frequency. So this is 1, right? So basically the K is the partial sum, and the value will be the frequency of that partial sum. So this way we can do counting. And then we initialize in variable S. This is the partial sum. It's going to be a running variable. Then, because we are not interested in the indices at all, so we just iterate over this nums. So once we look at a number, so S is incremented by this y, right? Then what we are going to do is we want to check if s minus go is in the dictionary, right? If so, it means in some previous indices, this sum has appeared. But we know, including the current y, so the sum is s. So in other words, from the previous, let's see, so s minus go in D means so this partial sum appears. So let's say appears at some index I naught up to in, right? So IL or IK, something like this. It means the frequency is k plus 1 times. It means that so from I naught plus 1 up to j, and from I1 plus 1 up to j, and from IK plus 1 up to j, all those subarrays will corresponding to a sum go, right? Because from those indices ending at j, it will have some s, and then before it will have s minus go. So this part will correspond to partial subarrays with partial sum go. So if this is the case, so we are going to increment the result by d s minus go. That's our logic. So no matter what, we are going to, because the current in the partial sum is s, so this partial sum appears at least once. Or more precisely, we need to increment it once. So we get this one because we are not sure if s is in the dictionary or not. So if not, we're going to set the default value to be 0, and then we increment by 1. So this finished our main logic. So that's after this, we exit this for loop, so we get all the information. So we just need to return those results. So this forms a solution to this problem. Let's do a quick check. So you see, for this first example, you get 4. So you can test this one, but it will pass. So here you can see 0. Right, so I get, right, it passes all the cases. So now here, let's make some remark. So if you want to find all the subarrays, you can actually store the indices, right? So in here we start the frequency. So here you can add the indices. So let's see, in enumerate nums. So here 0 I can use index -1, right? So in this case, if you have this one, what you are going to do, because if we are storing the indices, so we want to get the length of that list, right? It's corresponding to those partial sums, and then ds will be like this. So append so the index for this I. So we can do something like this. D is collections, default dictionary. So we use a list container or list of functions. So and D, so this one I'm going to set it to be -1. So then you can see this. This is also right, and let me first check it right, and then we print some more information. And it passes all the cases, but in this case, I can get all the subarrays. Let me do that. So in this case, what we can do is that for index, in the s minus go. So subarrays append, so a subarray. So what we are going to add is this. So add x plus 1 up to the current index I. So we write I plus 1. Let's look at this using example 1, right? So we can do copy this one. Let's first run it. So the target is 2, right? So let me print out this subarrays. So you get those 4 subarrays, right? 101, 1, then 10, 10. But you know, here you have 2 101s. That's not good. Maybe we can just print the starting index and the ending index. So we can do things like this. So we can put a tuple. So index plus 1, and this is the starting index. The end index will be I. So you will get something like this, right? From index 0 to index 2 here. And from 0 to index 3 corresponding to this one, and from index 1 to index 4, right, corresponding to 0, 1, 0, 1, and 2, 4, so corresponding to index 2 up to 4. So this is basically gives you lots of information. But another thing I want to emphasize is that, so this in general we don't need for this problem, right? So this is just more information, right? But for this problem here, as I mentioned, so you can do things like this: d 0, -1. So this is partial sum and frequency, and then I don't need this index, right? So also I don't need this enumerate, and then I also don't need this part. But but I do want to print out more information so that you can understand the details. So here is d get s, or default 0 incremented by 1, and then return the result. So I want for each step you can print out the status of s and the d, s, and the result. So we can do things like this. Print. So before enter the current value, so result state. So let's say d state is d, right? And s is s, and result will be result. So after we process this value y, so what we get is here. After, right? Let's also print another empty line so that we can separate all those. So we use this example again. Let's run it. So here, integer have no length. I see here. So just need this one. Right? You see why it's result. So here -1, s equals 0. So s minus go, then d ds. So here, let's see where it's wrong. So s, also here it's not -1, it's +1, because not indexed, but its frequency is 1. So let's see. Let me first make sure it's correct, right? So let me comment this one and submit it. That's more. Yeah, so it works. So now I just comment out this one, and so let's print out the information. So here you can see, so before this is the state of the dictionary and the result. Then after we press 1, so 1 appears once. So this is dictionary state, and s becomes 1, and the result becomes 1. So if I look at 0, so basically before this will be something like this, as this line, and then the sum is still 1, but here 1 appear, so 0 appears once, so 1 appears in two indices, right? If you ending here, you have some 1. If you ending here at this 0, you also have some 1. So then you can continue, right? So if you look at this index 2, so then before this is the same as here, and then the s will be 2, but s minus the 0, because we have a 0 appears once, so you get 2, right? So then in this case, the result is incremented by 1. So that's the logic. So you can put it here, right? So to get the details. So this is the one remark. Another remark is that there are quite a large number of problems in leetcode. You can use dict and check, or set and check. But the thing is that according to different problems, you need to write some extra logic. As here, we use the partial sum, right? So with that said, I guess that's basically about it for the current problem. Hopefully, you can digest all the details, and also you can expand and solve using this current video and the ideas here to solve more problems. If you like, you can also follow up or practice our channel to see more problems. With that said, that's it. Thank you.